This is Dave. I'm Dale.
Good morning.
Morning. Yeah, Dave's he's going from one session to another. It's all. Dave gave the pre-conference seminar on Python.
Right. Yeah, on Monday. Is anyone in that actually?
Yeah.
Yeah. So conceptually, we're covering some of the same turf, but Dale's much more of a poet than I am. So.
Well, I don't know. I've taken a 75. Well, it took a 90-minute presentation, took it down to 75 minutes. Now I've taken it down to 60, and I don't. Well, no, actually, I've taken it down about 20 because I want to really turn it over to Dave. So we kind of went through these questions. This is a kind of food for thought, but who do you develop for? There's really kind of three tiers of this. You develop tools for work within your own GIS shop. Right? How many people do that? You build a tool so that you process. Look, about half of you looks like. How many people develop tools to give or sell to other GIS shops? Okay, that's interesting. I mean, that's what we do. Like our spatial statistics toolbox is all made with Python. They're all Python script tools. You can go out to the model and script tool gallery. People put script tools out there. I can show that later. How many people are building services out of them? Wow. Okay. That's good. So you can think of building services as building geoprocessing tools for consumption by the non-GIS user. So pretty much, you're developing for things in your shop, GIS users. I know you may not think of them as that way, but they're using ArcMap and they're getting things done. So as you know, there's three types of geoprocessing tools. There's the built-in tools. Those are the ones that we build with a compiled language, C# or C++, and using Arc objects. You can build them with other languages. There's model builder tools built with model builders, and there's script tools, which includes Python toolbox. And that's what we're talking about today. There's two ways to deliver a script tool. You can either do it in a custom toolbox, which is the way you had to do it until 10.1, right? That's when we did a Python toolbox. And the way you do that, there's a little graphic up there, and that's what I'll be doing. The first part is I make a custom toolbox and you add a script. You go through the script tool wizard, and a script gets added to your toolbox. New way is with a Python toolbox, and there you actually right-click in a folder and say New Python Toolbox from the catalog window. Say New Python Toolbox. And that was introduced at 10.1. So one of the things we can get to at the end, which one should you choose if you're using script tools today? At Script Tool Wizard, why would you want to use a Python toolbox? Well, there's reasons for that. And there may be reasons not to use a Python toolbox. They both have their pros and cons. And the Python toolbox are really powerful, especially if you're a Python, you really are comfortable with developing with Python. So today's agenda, I want to introduce, I'll do the introductory stuff about what a tool is, what it does, and demonstrate it with a Script Tool Wizard. The only reason I'm really doing that is that it sounds like a lot of you have done a Script Tool Wizard. It's just easier and faster to talk about the concepts there because I can change something, run the tool, and you can see the difference. Mm-hmm. And once I've covered the basics, I'm going to just hand it over to Dave. So we're just going to tag team. I'm going to cover the basics. Dave's going to go into the Python toolbox. So I like to think of a geoprocessing tool does three separate pieces of work. As you know, it defines the parameters that you want the user to enter. Those are both input parameters and output parameters. So give me a layer and a field and a number and a string and an option and a Boolean true, false, and push the OK button and something happens and then the work gets done and then the layer gets added to ArcMap, perhaps. So a tool defines its parameters, what it wants. It then validates those parameters before it executes. So it says, I can't execute because I asked for a point feature layer and you gave me a raster. That's not going to work. And then the final piece is it executes code that performs actual work. And we're not really going to get into that today, the executing the code. That's all what Dave covered in his workshop, how do you write Python to actually do useful work. This is all about making a tool in a toolbox. So read the doc. Everything we talk about today is in this piece of the documentation. In 10.1, it's under Desktop Geoprocessing. There's a book called Creating Tools. And there's two books in there, one about creating tools with Model Builder, and the other one's Creating Tools with Python. Everything we talk today about will be in this book, Creating Tools with Python. And I believe, I don't know how many languages, I think it's up to 6 or 7 languages now we've translated to help. So it's there. Everything we covered today will be in there, and occasionally we can refer to that doc. So I just want to go through a quick demo adding a script tool to a toolbox. First, let's start. If you're going to add a script tool, you usually start with a script. You write a script, and here's my script in Python, PyScripter. What it does is it takes a feature layer or table, anything that has fields on it, and rows, and makes an HTML report out of it. So I need 3 things from the user. I need the name of that table. I need a list of field names. And we'll get into that in a minute, but the fields on the table you want to report on, and the path to the output HTML file. And I'll just scan through this code real quick. We're going to open up the output file using Python open, and then we're going to write some HTML tags like a header, heading to header. We're going to then write the table tags, table borders, and a table row, and some stuff. And then we're going to just open the search cursor on that input table, loop through the fields that we've asked to report on, and then check for a null value. If it's null, we put in a token non-breaking space, or then otherwise we write out. And then when we're done, we close out the HTML brackets, and we're off and running. So let's go ahead and make a tool out of that. So I'll just go here, and I'll say New Toolbox. Oh, no, here. Thank you. New Toolbox. So this is called a custom toolbox. We'll just leave it at that. Open it up. Add a script. So we'll just call it a session. Whatever. Script file is this script I just showed you here, table HTML2. So now I'm ready to define the parameters. So my parameters have to match up with what I have in PyScripter. My first parameter, 0, is the table, then the fields, then the output. So input rows, data type. And the data type I want here is a table view. Table view means anything that has a layer or table view, and it is a table view is a table in a table of contents or a table on disk. And it's a required input. Next thing I need is some fields. And I'll put in F for fields. And I want multiple fields. So I'm going to say yes to this multi-value. And then I need an output, yeah. And that's going to be a file. And I'm going to do this. And since it's a file, I can say it's an HTML file. I can say, hey, I want a extensions HTML on here. Okay. I'm going to finish this up. Oh, it's did I make sure this was output? Nope, it's an output. Okay, finish. I can now open this tool up, and there are my parameters that I've made from the script tool wizard. So this is all about defining parameters. I can now choose one of my tables from the table of contents. A layer is a kind of table with shape on it. I can browse to tables on disk. I'll take major street here. And where are my fields? I have an output here. I can go to my output, and I can say that's my file. It tells me that already exists. But does anybody know why I don't have any fields? Excuse me? Right, we got to associate that. So let's go back and look at the properties of this tool. Look at the parameters. So the one thing that I want to that's a property of parameter, which is very important, is this thing called obtain from. So if I'm going to get a list of fields and present them to the user, where am I going to get those fields from? I could have 4 or 5 different inputs. Where am I going to get the fields from? So right here, there's this property called obtain from. And when I pull down the drop-down list, it says, well, what's the name of the parameter from which you want to obtain your fields? In this case, it's the name. It's my first parameter. The only parameter is the input rows. And the parameter name is shown down here. It's the parameter label with all the spaces turned underscore. So I'm going to choose that, hit OK. Now we can go and look at our tool here. Input rows, I give it a major street, and there we are. And I can choose the rows I want to show, or the fields I want to show. I'm not going to talk about the automatically generated name. Okay, so I can run it. I completed the script. I can now go to my results. I ran my tool. I got a result. I can double-click this, and it adds it to, since it's HTML file, it knows to open up my browser and adds it to my browser. Something I want to demonstrate quickly here is that because it's something in a table of contents, I can select a few things. And now when I run this tool again with the same parameters, I should get far fewer, and I will, records. So one of the things about layers and table views is that when I pass that thing in, it honors that selected set. So it only reported those things I had selected. That's a feature of a layer, feature layer, raster, feature layer, or table view. Let me go back one last time. A few other things I can do on this is properties. We saw me setting a field filter before. I can set a filter on my fields. I can say, look, I'm not going to try to put any of these things as output to my output. I'm not going to report on them. If I hit OK now, you'll notice when I open this up and I give it my input that the shape field's not here. Or are there any blob fields, which I have none or anything like that. But the shape field's not there. If I go in, I say, hey, you know what? Don't even show me, don't show me the OID field. And when I run this thing again, excuse me, notice that object ID or feature ID isn't there. Okay, so that was just real quickly about how we define parameters and hook up a script to it. So let me get back here and let's just see what I missed. Here's my review. Okay, so what you saw in the script was I received parameters in the script as get parameter is text, and it's a zero-based index, so the first parameter is index 0. Receive it in the script, and I then start doing my processing. So how I could use the add script tool wizard. Parameters, you saw how they have a label, they have a data type. Now, I wasn't planning on going into data types today, but we can. I think the most, there's a write-up in the help, I think, about it, but the most common data types are feature layer, layer and table of contents, or a layer file on disk, or a data set on disk, table view for anything of table, field, then things like doubles and booleans and longs and shorts and things like that. Those are standard data types. We have many, many more data types for things like raster layers and tins, and it goes on and on. They have a direction, input, output, derived. I'm going to talk about derived a bit. Required versus optional. An optional parameter is one if they don't give you a value, you're going to supply one. You can put filters on. I showed doing that with the HTML output and the fields. I set that obtain from. That's a really important property to know about a parameter. We're going to use it. We can use it in other ways too, but typically it's used for fields. Tell me which parameter you want me to get the fields from. Multi-values. We set that field to a multi-value, meaning you can pick a list of values. If I didn't do that, it would just be a single value. If I went here and I said properties, went to fields and said it's not a multi-value, and then I run this thing, it's entirely different. It's only going to give me one field to choose. I don't want that in mind. I'm just going to say, hey, I want to have a bunch of values. Now, when multi-values come into your tool, that's right here. I'm getting the list of field names. They actually come in as a string separated by semicolons. Here's a string with all the fields we want to report on separated by semicolons. So your favorite friend in Python is the split directive, which says, take this string, split it on a delimiter, semicolon, and give me a list. And that's what we do here. We use that all the time. That's very, very common when you're writing script tools and dealing with multi-values. Here we go. All right, so moving right along, here's some of the filters you can set. It's all in the doc. So next thing I want to talk about is output. One of the things is when you build tools, the number one rule is you can violate all the rules you want, but number one rule is tools must have output. And sure, you can build a tool that doesn't have an output and you can use it, but it will be no good in Model Builder. You build tools so that people can put them in Model Builder and use them. And if they don't have an output, you can't chain the next tool to it. Everybody uses Model Builder. You know how you string tools together and you take the output of one and feed into the input to another? Well, a tool must have output. So this is a good time to talk about output. That's a parameter. There's two types of output for a tool. The first is a required output like I had here. Hey, give me your input table and tell me the name of your output file. And that's a required output. You're going to I'm going to give it to you. I guess there's an optional output. We won't deal with that. That's just kind of funny. If you give it to me, I'll write it out. The one I really want to talk about is derived, which is the output is derived by the tool. So here, think of something like calculate field, right? Everybody use a calculate field tool. You give it a table and you fill an expression. What's the output of that tool? Well, it's just the same as the input. The only difference is that some of the fields have been calculated on it. So derived outputs are thing as an output of a modification of the input data set. Or maybe the output's not a data set at all. Maybe it's a number, like you're going to calculate some weird value. So it's going to output a number. Or the output is determined by the tool. You're going to take some things like the name of a workspace and the name of a folder in a workspace or a file geodatabase in there and the name of a feature set or something like that, and then you're going to write a bunch of stuff to it that you don't ask the user about. And with derived outputs, there's this thing called, within ArcPy, called set parameters text. So if you have a derived output, your tool you have to call this set parameters text. So think about it. If your tool calculates a number, where do you report that number? Well, you got to say set parameters text to the output parameter. I'm just going to go through these real quick. Derived data, the output is set to derived. The examples, get count. Get count is the one where it just outputs a value. Hey, give me the count of records in this thing. Calculate field, exact copy of the input. Add field. Add field is exact copy of the input with the extra field added. Create feature class creates new data. I have a link to the topic in the help system called Setting Script Tool Parameters. In that topic, it talks about derived data. Talked about scalar values. Classic. If your output is is something that's scalar value, like a long or double, your only choice is derived, because we don't write numbers to disk. We only write them to the result. And if you're going to do that, you need to do set parameters text as here. Output same as input, calculate field. Modify the input field, and then something like create feature class, where you give me the name of a workspace and the feature class to create, and I actually create the output, which is a new feature class on disk. And that's another case where you have to use set parameters text. So we talked about defining parameters, talked about input parameters, doing that with a script. Now I want to say an output parameters. Something you have to be aware of is this derived from. Now something I skipped over is something like calculate field. If you have something like that, and I think a lot of you do, you have a tool that takes a data set in and calculates a bunch of existing or new fields on it. The output of that is derived. It's the same as the input, and that's another place where you use that obtain from flag. You say, hey, the output's a copy of the input. Obtain it from this input parameter. So the next part of this is validating parameters. Why do we validate? It's a better user experience. We check the validity of all the inputs before the tool is executed. So if I'm asking you for a number between 1 and 100 and you give me 101, I'm not even going to execute. You push the OK button, it says, I can't execute. I want a number between 0 and 100. You just gave me 101. The other purpose of validation is, the better user experience is also painting the UI. Hey, if you give me something here, disable that parameter. Let me calculate a default value. The other reason you would do validation is to describe the output of the tool before it's executed for model builder chaining. So think about the add field tool, where you're going to add a new field to the data set. In model builder, you get to see that before the tool is executed. We'll talk about that in just a moment. So there's two types of validation. There's internal validation, is what you get for free by using like the script tool wizard or Python toolbox. When you define your parameters, say, hey, I want a feature class that contains points. I set a point filter on it. And it's required. before you execute the tool, we'll check that for you. Oh, is that feature class a point feature class? And is it filled in? Is the value in range? You know, if I'm asking for a number and you gave me the letter A, I'm going to not execute. I'm going to validate for free. You get all that stuff for free. Does the input or output exist? The values match their filter. You know, if I say I want a field, you can't give me the shape field as input, and you give me the shape field as input, I go, no, I don't allow that. Then there's full validation, which is something you have control over, which is these goodies like a dynamic choice list. Where if they choose something here, like new layer, another drop-down list gets populated with more values. You can give custom error messages. You can enable and disable parameters, as shown at the bottom. You can put things in categories. You can provide default values for parameters. And then this big idea of describing the output before the tool is executed. Here we are in Model Builder. We're using the script tool from the Spatial Statistics toolbox. It's going to give you a result table that has these fields on it, and it knows that before it even executes the tool. That's kind of important for chaining a Model Builder. So the way we do that with script tools is something called a tool validator class. This was implemented in 9.3. It's a Python class you program. It gives you the full control of the dialog and allows you to fully describe the outputs for chaining a Model Builder. So one of these things that validation does, this thing about describing the output, is actually, when we talk about defining your parameters, well, when it's an output parameter, you can't fully define it until you've kind of got all the other inputs collected, and then you can fully define the output. That's what's done in validation. So a tool validator class, and Dave's going to show this because it's in the Python toolbox as well. It's three things: initialize parameters, what to do when the tool first opens up; update parameters, what happens every time something happens on that tool user interface; and then update parameters is called update messages is called after update parameters. So basically, tool opens, initialize parameters get called. You can put some values in there if you want default values, set some things up. Every time something changes on the UI, update parameters gets called. You're able to validate it, able to enable, disable parameters, and after update parameters is called, then update messages happens, and that's where you get called, and you can do some things with messages. So a real quick demo here. Let me show you this little tool here that does nothing other than show off some things you can do with tool validator. So imagine this is a tool where, I don't know, you guys got a custom in-house format, and you give it a file or a table, and the user fills some things in, and then you go out and create a feature class. Again, this is a total nonsensical tool. But, so for instance, I give it a table. I can say, hey, this is my primary field. This is my secondary field. But look at this. I got a custom error messages that says, hey, your secondary field can't be the same as your primary field. So I'll just give it something else. We're good there. Hey, what type of format is it? Oh, it's the new format. Okay, so you can have points, lines, polygons, annotation, or dimension. You can also choose old format. If it's old format, you only get point, line, polygon. If it's point, then this option becomes enabled. If it's line, then this option becomes enabled, and point option gets disabled. If it's polygon, they're both disabled, meaning that they don't apply the tool and you're going to ignore them. Notice I got this category here. All this stuff was done with this tool validator class. So let me show that to you. You get to the properties of a tool. Here's the validation tab. I love this. You can't change the code in here. Anybody watch Stephen Colbert? You ever see him every night? He does this thing? You know, it does. Okay, I guess you don't get it. Okay. You can type all day long here. Nothing's going to happen. What we want you to do is push the edit button. And what that does is brings up your IDE, whatever you've registered as your Python IDE, and opens it up on your validation code. And now you can change it here. So let's just go ahead and I got 2 more minutes here. As I said, here's the class itself. Initialize parameters. I'm going to set up some categories. I'm going to put some things in the list, like old format, new format. I'm going to put some things in this list. I'm done. Here's my update parameters routine. This gets called every time something happens on a tool dialog. let's go ahead and put add something to this. All right, good, 2 quotes there. I can, I probably don't want to add that there, but I'll leave it there. And I'll just put another one here. Oops. Okay, so what's happening here is that an update parameter is based on, hey, if the format's new format, add these things to the list, drop-down list. If it's a point, add what type of point. You got a single point, multi-point, or hello. I'm enabling and disabling parameters here, and this is where I check that the 2 fields are not the same, and if they are, give the message. I'm now going to push Control S to save this, and then I'll just go ahead and close this here. Now when I go in and say apply, it reads all those changes I just made in my IDE and puts them up here, and you can see it here to check it. I believe we should see the Dev Summit 13 here, something. Yeah, here we go. So I can see that my changes were made. I hit OK. Now if I do Tool Validator, I give it my major streets. I say name, type. There's my Dev Summit 13. These are both disabled because it doesn't recognize what they are, but if I say point, this gets, and that's my hello. So the idea here is that what I've done is I've used this tool validator to take full control of that UI, dynamically update lists based on options. So for instance, if you choose polygon here, new format here, if you choose old format, it's just got point line polygon, but if you choose new format, you got all those plus Dev Summit 13. So back to the slides real quick before I turn it over to Dave. Try to kind of get a summary here. So basic tool validator. So I just showed the basics of what a tool validator is. It's a class. You can control things in the UI. Again, it's all in documentation. It's kind of funky how you edit it. You go to the properties window, you hit that edit button, it brings up your IDE, you mess around with it. You can do things like set keywords, set categories, update those keywords list. All that stuff a basic validation can't do. One thing I want to talk about, we see occasionally, is don't open data sets in your tool validator. You walk away from it and go, oh man, tool validation is great. I'm going to write a tool validator. It does just what I want. I hear this a lot. People want to send tool validator, open up a data set and scan a field values to get the unique values of all the fields, like the unique list of zip codes, to choose one. That's not what validation is for, and there's really 2 reasons. One is that geoprocessing was designed as a stateless machine where data doesn't exist. And if that data, you have no guarantee that the data that somebody's giving you, yeah, let me open up this table, exists. Think about Model Builder where you make a feature class on disk and it doesn't exist until you run the model. So you don't open up data sets in Tool Validator. And then finally, I talked about this earlier. You can use Tool Validator to describe the output with something called a schema. If you used add field in Model Builder, you add a field to a data set, and then you got the calculate field tool here. You chain it up, and lo and behold, calculate field sees the field you're going to add before you even run that add field tool. How's that possible? That's what we call describing the output, and that's how Model Builder works, is that we're able to describe the output before you run the tool. And this is what enables that nice chaining in Model Builder. Now you do that in a Tool Validator as well. What you can do is in Tool Validator, when you get an output parameter, you can say, give me the schema of that output. And I want to set some rules on there. You say, okay, use the fields from the second data set, or get the fields from the first and second data set and glom them together and put them in the output. Oh, use the fields from this input, but add these new fields as output. Oh, that data set's going to have the extent of the second input data set. That's what the schema object gives you. And so what you can do is go ahead and here's some of the properties on here. We can talk about this in detail later. But anyway, that's just a summary. We talked about tools do 3 things. They define their parameters, they validate their parameters before they execute, and then they execute some code. And you can do custom validation and you can do let default validation take over. And now I'm done.
All right, Dale, how do you feel?
Good. I blasted through that. We're okay with that? Is that we'll find out.
Yeah.
Let's get into Python.
Yeah, I mean, part of the point of that is, you can show how to do, the changing the various things very easily inside the script tool wizard. And, when you actually get down to it, most of the concepts are really all the same thing. Like, the way you do parameters in a Python toolbox versus a script tool are different, but, fundamentally they're just parameters, right? And, actually big chunks of it, like the validation, is almost exactly the same. It's just, very small differences between the two. So yeah, a Python toolbox is something we added at 10.1, and it's not a replacement for script tools. It's just, script tools will continue to live on for, a long, long time. It's just sort of a different way of doing it. What it really came down to, we kept getting requests from people who, who are creating, more than just one or two script tools. And when you create a script tool, there's all these parts that you sort of have to manage, right? Like, you're creating your tool and you create these parameters, and then you also, you go through the wizard to do that, right? And you're clicking all these buttons. And then, you start adding some validation, right? And, you make a mistake in the validation. There's like 3 or 4 button clicks to get in, and then a couple of button clicks to get out, and then you make a mistake, and, there's a lot of this back and forth stuff, right? And a Python toolbox, really, you can get it all in your face all at once, and you can make, one change very easily, and have it reflect, instantly inside the application and kind of move forward, right? What we really want you to do is be able to invest your time in, what the actual source code of the tool is, right? Not be fiddling constantly with parameters. You do it actually, all in code. So when we think about how a Python toolbox is structured, it's a PYT file, so it's all one file, and it's defined by classes. So we have a toolbox class, which is kind of a set few lines of code that you'll always include in your PYT file. And then you'll have one or more tool classes. So inside that tool class, just like Dale was kind of explaining the 3 big parts, you define your parameters. There's a few different optional methods for dealing with validation, and then the actual, the source code, or, where the magic lives, right? That can all be in the one same file. So, I'm pretty much always into Python, and, I'll get, emails and requests and questions of people looking to how to accomplish, some basic piece of functionality that doesn't, already exist in the system, right? You have some larger workflow, and you can break it up into tools, but there's just that, one little piece missing. So for instance, I often get little questions like this, right? Basically they're trying to do just that. So in this case, they had a series of, line feature classes that they wanted to be able to create, points from that. Basically, at some fixed interval along the lines, create points, right? It's very easy to go the other way. Actually, we have a tool to do that that's in the system. But going from, lines back to points, not just the vertices, but at a distance, is something different.
I think I was on the CC list of that one.
What's that?
I was on the CC list of that email. I remember that.
Yeah, I think so. Yeah, it wasn't but a year ago. All right, so the amount of code to do that isn't actually all that complicated. We'll just go through this here. Basically, I'm bringing in some input values, but I'm just going to be creating a feature class, and then essentially with using the new 10.1 cursors, I'm opening a search cursor on my input lines. I'm opening an insert cursor on my output point feature class, and basically I'm just cycling through the geometry, working through where those points should fall, and then populating them into the output. Now, to actually, but I want to take that now and make a tool around it, right? So we can do a Python toolbox. In any folder, you can right-click, go new Python toolbox. And this creates, sort of that stub for you. So what you saw on that one slide earlier basically creates all that for you. You have a essentially non-functional tool. It's just the shell of that tool. if you ever want to look at it, you don't right-click necessarily on the tool itself. The file, right, is the Python toolbox. So you right-click on the file. You can edit that. So that'll bring it up in the IDE.
Well, that was interesting.
What's that?
Well, PYT is not a Python file.
Right.
So what he had to set the syntax to Python to show it to be Python because didn't know what it was, right?
Yeah, there is a way to do it. Actually, you can make it fairly quickly, but
Sorry, I'll show you.
I did it once and then undid it for some reason.
I wonder why you were doing that.
Yeah. So yeah, so it's not like a Python file, but the code itself is all Python. In any case, so you define. It's a very simple structure. The toolbox class is just defined with this toolbox class, and the one key is the name always has to be toolbox. That's sort of how the system recognizes it to be what it is. The actual name of the toolbox you see in the application is actually based off the file name. Then in terms of the tool, well, yeah. So you set the label and you set the alias. The alias is always important when you're setting tools. That helps make sure that when your tool is used, it's unique, right, compared to other tools that might have the same name. And then you set this tools property at the end to a list of tool objects. And that's what we're going to create down below. So at the beginning, you have this tool class, just named tool. The way it's structured, you set some very high-level information on this init method. You define parameters through this getParameterInfo. There's a series of optional validation methods which you can use if you want or not. And then the fun stuff goes down and execute at the bottom. Go. So just to hasten this a little bit, I copied out some of the code already. So I'm just going to replace the toolbox class and the top of the tool class. Now the nice thing about Python toolbox, right, is very, you can reflect what you've done very, very quickly. So I made that change, I saved it, I come back in here, and refresh it, and updates come very quickly, right? So that's one of the key factors. If you're working on this, you're trying to get it right. Any changes you make, you can instantly see how they come about, right? This was like a function tool. You're going to have to deal with things like registering and all that kind of business. A Python toolbox, it's all very, clean and instant. And when we actually look at what the Python toolbox structure is, the biggest change, I guess, from what you've had to do in a script tool wizard is how you define the parameters, right? And in the script tool wizard, you go through that wizard and you click all sorts of buttons. In Python toolbox, it's defined using parameter objects. So in ArcPy, we have these parameter objects that you can use to do that. So let me copy this out. All right, so it's just a simple ArcPy parameter object. And really, there's a whole number of properties that you can set on a Python toolbox or a parameter object. But really, there's 5 that you're always going to need to set. The display name is what you're going to see on the dialog. And if you double-click and run the tool from in the application. The name is what you would use if you're calling the tool from code. Like if you ran this tool from Python, reference the name. And then the data type. Now, the data type is a big consideration. Now, there are actually about 130-odd data types, but in my experience, it really comes down to you have about half a dozen to maybe a dozen data types that you're going to use pretty much all the time. So things like feature layers and strings and booleans and table views, things like this. Now, all these strings are documented if you need them, but after a while, right, it's the same pattern, the same parameters again and again, so you just kind of intuitively start to learn them. Then, of course, it's parameter types, so things like if it's required, optional, or derived, and then direction, input, or output. Now, in my particular case, I want this tool to only work on line features, right? It's going to take the line feature classes and derive points from them. So I can use a filter. So every parameter object has a filter, and then depending on what it is, you can filter that down. So in this case, it's just going to be just a list with the one type that I want, which is polyline. And then I have an output feature class, sort of defined very similar to above, and then I have an interval, which is just a numeric value. So now if I save this, come back, refresh it. All right, so basically at that point, right, I've defined the entire outside of the tool, right, all the parameters, all the sort of structural stuff that needs to go around the tool. I've got pretty much everything I need. Now it's just really a matter. I can go in and make some changes on the validation, but in this case, I'm actually just going to leave it blank. So now I can take this code that we looked at earlier, I can drop it in here. All right, and save. The key thing to look at in the execute is the parameters or the arguments that come with it. So, all the validation routines, parameters are passed in using a list of parameter objects. So the same thing happens inside execute. Now, when you receive the parameters, there's really, in execute, the only thing you want is the value, right? So there's a couple ways of doing that. You've script tools in the past, you have this concept of get parameter as text and get parameter. Well, the equivalent in a Python toolbox is value as text or value. So you can get either as a string or whatever the best match on the type is. So intervals coming in as an integer, I'll get an integer in this code here. Let's just save that again. And then it's to reflect that and have the toolbox recognize the code. I just refresh it one more time. All right, now I have that fully functional tool. So I can double click on it, and now basically I got all the, everything I need in the tool. So if I want to, use my input rivers here and do that, the output will auto-populate based off of that. I'm going to modify it to that, and then I can put any, distance value that I want. So let that run. That should take about 10 seconds. Okay.
Oh, you're off by 63.
I always add a couple seconds because it always runs longer when you're having someone watch it. But. All right. So yeah, and then the output's created and added to the map. So all the behaviors that you get with the geoprocessing tool, right, are just kind of automatically built in. And it's really just a matter of getting the parameters right, getting the validation that you need, if any, and then the execution code, right? All right, so one key consideration with parameters is, well, is anyone on 10.1 but not 10.1 SB1? Like haven't updated to a service pack yet? Okay. There's a small difference in how we define parameters. When we did this initially at 10.1, parameter objects, which have actually been around for a while, are localized. So the data type is specific to the language. All right, so if you were on German, you'd have to figure out what the equivalent of feature layer is in German to get it to work correctly. At 10.1, we kind of solved that by actually putting in a fixed list of keywords that are locale and specific. So regardless of what language of ArcGIS you're working with, if I specify it as GP feature layer as opposed to feature underscore or feature space layer, it'll work for everybody across all. Now with Python toolboxes, we actually have two parameter types that you can't, or two data types that you can't do in a script tool. So the first one is a value table. So if you think about, say, a tool like summary statistics or a lot of the overlay tools have this kind of value table like control where you're essentially got a combination of data types mixed together in sort of a table format. Now, you couldn't do that in a script tool, but if you want to do that as a Python toolbox, you set the data type to GP value table, and then you can set this columns property either to a list of parameter objects or a list of these parts, right? The type and a label. Now, unfortunately, the value table isn't as I guess sophisticated as I would like yet. So, for instance, if you wanted to create a value table that has like a drop-down list, you think about like if someone's used summary statistics, right? You can specify a field, and then there's this little drop-down list of the different stat types, right? Don't have that capability yet in Python toolboxes. Hopefully coming soon, though. So, the second data type that you get that you don't have in Python toolbox is something called composite. So, classic case of that is in the buffer tool. So if you use the buffer tool, right, when you're specifying the distance, you can either do it through a number you type in, or you can do it on a field that's based on the input, right? And the buffers are based off of those values. If you want to do something equivalent in Python toolbox, you just set a data type to a list of those data type strings, and then you'll get those, because typically a composite data type kind of marries, two or more sort of incompatible data types to two things that are, significantly different, right? So you can pass all of that in with one value if you set it to a composite. All right, so just get into validation a bit. Dale kind of went through this a bit, but validation, right, is basically everything that happens before you hit the OK button. Now, some of that validation comes for free. Like when you set the parameter object, things like the data type, are automatically take care of making sure that the data type is actually correct, or whether the value that you put in, follows certain criteria, right? Like if it's an input feature class, if it doesn't exist, right, the tool is going to tell you that, or these kinds of things. But there's extra validation that you can modify to make that a little bit richer. So Dale talked a bit about schema, and this schema kind of sort of crosses the boundary between validation and parameter objects. You can actually do it in both places, at least in a Python toolbox. So we need to define schema when we have the potential to be chaining tools inside a model builder. And it's so that tools downstream can connect and know aspects of what's happening with the original tool, right? So you have a tool that adds a field or changes the spatial reference. You can define a schema with those kind of characteristics so that tools downstream can behave as expected in relation to that tool. So in this case, let's take a simple case. Say you have an input feature class and an output feature class, and that's the whole complement of the tool. But inside the tool, it's going to add some field. So basically, the input and the output are going to be virtually the same, right? Just with that extra field. So if you imagine here, all parameter 0 and parameter 1 are already defined. So I just set my parameter dependency back to the first parameter. Now, when Dale was showing that in the script to a wizard, I think the actual thing is obtained from. But this is the equivalent here. Then I'm just cloning it. And then I can update the schema. In this case, all I want is that field. So I'm going to create an empty field object, set the properties on it that matter. So in this case, the things that are really only probably going to be relevant are what the name of the field is and what type it is. So if I have a tool that connects to this tool that uses the field, it'll understand first that the field's there and what it is as well. And then I simply take the parameter object, the schema from that, and I'm going to update it with this additional field property and set that to a list of just that one field. All right, so in Python toolbox, there's three optional validation methods. Update parameters is one of them, and it's actually basically exact equivalent to update parameters in a script tool wizard. So we use that to basically fine-tune how the parameters work, right? So how they interact with values that I supply and values that may come into a different parameter. So in this case, you can imagine a tool where I have, say, like an input feature class as the first parameter, and several parameters down, I have a parameter that really is just a distance. And I want that distance to be sort of based on that input. So what I'm doing here is basically checking if my first parameter is a value, and if I haven't already altered this distance value, right? I want to keep anything, my user might use to change it, right? So if the first one has a value and this last one hasn't been altered, I'm just going to describe my input, get the extent, and then based on the relationship of the width and height, I'm going to update this last parameter. That in principle is kind of the one fundamental kind of type of thing you would do in update parameters. So when I do validation, actually most of it's in update parameters, right? Occasionally, though, you want to put some kind of message back onto the tool. There's a lot of things like how the data type is set that will also give you messages, but if you want to provide more, you do it through update messages. So in the example here, you can imagine a case where I have a tool that I want to work only on version data, right? That's just an important part of what this imaginary tool does. So basically, I'm just going to make sure that everything's kosher here, and then I'm going to describe my input, see if the is version flag is true or false. If it's true, the tool will just be allowed to keep working. If it's not a version feature class, I'm going to throw this error message onto the parameter. There's a little red icon, so no one will actually be able to execute and enter the tool until either the input's been changed or something else is done to correct it. The last thing in validation we have is this is license method. So on a script tool right now, you don't have this kind of capability, but in some tools, say you have this workflow that's basically encapsulated in your tool, and it takes tools from extensions that someone you're giving to this tool to may or may not have, right? So you don't necessarily want them to run that tool, enter into it, and go halfway through the code and then fail somewhere later, right? You can put a check on it right up front so that you never actually get the opportunity to open the tool. So in here, imagine this tool requires the 3D Analyst extension. So I can check extension to see if it's available or not. If it's not, or this fails for any other reason, it's going to return false. False meaning that the tool isn't licensed. If it is true, the tool is licensed, and you can proceed as normal. When you interact with the tool, though, if it returns false in here, you're going to get this little icon on the tool, and a little error will pop up when you click on it, indicating that you can't actually use it. All right. So in the execution part is really where all the fun part happens, right? That's the part where you want to invest your time. Setting the rest of it right is just kind of the framework to make sure you can run your execute. The only couple key considerations in execute are, I mentioned already, the parameters that's passed in. You can access them as value or value as text. And then there's also this messages object. So you can, if you want, use all the equivalent ArcPy functions. So there's ArcPy add error, ArcPy add warning, those sorts of things. You can use all of those in a Python toolbox. But there's also a message object which has the similar type methods for adding messages as well. All right, so I'm just going to go through another tool. About a year ago or so, I had this fellow come to me. He was like a cartographer, and he was basically he had the idea already done. He just sort of needed some help and kind of implement it and put it into a tool. But the idea was, he wanted to be able to, put labels down on top of the feature class. But he wanted to be able to sort of flag in advance for himself if there was any labels that might potentially be problems. So, he was labeling things like rivers, which, can be quite bendy, and, labeling across, a very, twisted feature, might require some special circumstance or, special handling. So he wanted basically to identify those. So that code and the ability to do that is actually, already in the help. So Dale kind of mentioned the help earlier. So this is under basically that structure. There's a topic called What is a Python Toolbox? So what we're going to do, we're just going to create a new Python toolbox, edit it, and then essentially just replace what we had in the first place. The amount of code behind this is actually, is that right? Nope. Cut it off. Oh. The amount of code behind this is really quite simple. Really all we need to do this is we're going to add a new field to whatever feature class I have, and then it's just basically a simple calculation on top of that. So the way the calculation works, it's basically just the measure of the, the actual length of the feature versus, the length from the start point to the end point in a straight line. Just sort of a measure of sinuosity. And what I should get out of this for every feature that I have, calculate a sinuosity value. A very, curvy, bendy river type feature would get a number closer to 0, whereas a straight line would get a number of 1. So if we go back in the map and refresh, that'll just bring that toolbox right in. So in essence, all it really does, I can specify, my input line feature class. And then it's a field that is going to get added and updated as necessary. Now, one thing you can do anytime you have a tool, right, there's the potential that people can put in, really any kind of value that may not really work for the context of the tool. So, right, fields follow certain rules in terms of how they're structured, right? So if someone, put in something that was kind of rubbish, this is going to fail inside the tool if I just let it go in, right? So I added some validation to basically check that name and update it in place. Well, let's just look at the structure of that tool. So the parameters I set up are very similar to what I had in the first one. So I got an input features. I got a filter on that as well. Here I have a field, which I'm applying a default value through this .value property. And then like Dale was saying, right, we have to make sure we have tools that work well in Model Builder. So, I'm just modifying my input. I still need to make sure the tool has an output so I can use it in a model. So where that comes in, I just basically set my parameter type to derive. And then to make sure the output looks equivalent, right, when I'm chained in Model Builder, I just set my parameter dependency to my input. And then in the validation, I'm just doing a really simple check. And then I'm looking to see, when that parameter has a value, I'm using the ArcPy validate field name, and I'm going to bounce off whatever the user or whatever got put into the dialog, and I'm going to check it against the workspace of the input. And then it'll update it if necessary.
And then when does that update messages, you do add the field, right?
What's that?
And update messages where you add the field to the output.
Right. Yeah, actually, yeah, I don't, in that context, I'm not actually adding that. Okay. Yeah. I thought about modifying that, but it's in the help, so I can't just go and fake it. All right, so the tool, yeah, I can just add my rivers layer. I'm going to keep the actual original default field, and then I'm just going to let that run. So if I then check the output, well, actually, let's do it this way. Right, so if you look at this feature right here, that's a pretty long, sinuous type feature. If I check the ID on that, it should be fairly low. So you probably won't be able to read that, but it's about a 0.36. Very straight, more linear feature, straight line almost. Like this feature here, that's got a sinuosity value of almost 0.9. So again, the key really is just, getting the code right, and then, going through the Python toolbox to really create that framework around it. But again, the key really is always your execution code, right? You want to spend, really as little time as you can get away with inside putting the rest of them together. And I think the Python toolbox does that a little bit better than what a script tool does. All right, so I just really have one more point I want to make, and then we can call it a day. But when you create a Python toolbox, right? One Python tool inside, one tool inside a Python toolbox really isn't that much code, depending on what you do in execution, right? But in many cases, you're not going to be creating a toolbox of 1 or 2 tools. You're going to be creating them with like 10 or 15 or something like that, right? It can get really bloated in a hurry. So while you can put it all in one code or all in one file, you can break it up. So like the spatial analyst team, they actually went through an exercise with Python toolboxes. And what they did is they basically structured it so that the Python toolbox itself had almost nothing in it, right? It basically just had this sort of a minimum to it. And they wrote the tool classes in separate Python files and then just imported them in. So it's just, it's all in the end the same code. It's just, structured in a little bit differently so to help you kind of manage the bloat of one particular file getting a little too long. All right, I think it's 3:30. All right, so I have there's more details if you're interested in it, like the main help page for the Python toolboxes is that link there. I have written a couple Python toolboxes in the past, including some of the ones you saw today. You can reference through those links as well. And then if you have the time, Dale, and I would appreciate if you'd be able to go through the review process. So there's the link there. I think the ID for us is, 283. Yeah.
Questions? Right. Thank you.
Can you move to the previous slide, please, where you have the
Oh, yeah. This one? Yeah. Yeah, sure.
When you move your execution code to another class, I've noticed that you make changes to that, or to a new Python file. I've noticed that if you make changes to that other Python file while ArcMap is still open, like say you're running it from ArcMap, while ArcMap is still open, you have to close ArcMap and or just open a new one before those changes will take effect.
Right, so you're talking about like the structure where we were like dividing it up, right? We're pulling out parts of the PY. Yeah, it kind of, no, it doesn't refresh in the same way. It kind of follows the basic idea of how Python modules are imported. So when you, in Python, import a module that already exists, it just says, yeah, it exists. I'm not going to do anything. So, yeah, so that's the trick. You basically would have to temporarily, in the PYT, force it with a reload, and then you would get it anytime you refreshed it. Yeah.
Oh, so there's actually a reload function in Python? Is that what it is?
Yeah. So I don't know if everyone caught that, right? But
I didn't hear that. I really wanted to ask that same question.
yeah. So right in this case back here, right? So his context was, he wrote something like this, and then he wrote the actual tool class in a separate file, right? So yeah. So when you do the refresh, you don't actually see the changes at that point. And it's kind of just the way how Python imports its own modules. So in Python, when you import something that's already been imported, it doesn't actually like re-import it. It just says, yeah, it's there, and it skips it. That's how like the yeah. So what you can do, like if I had this case, well, I might have to do something like this. And then,
Reload.
yeah. Because you can't reload off a from module import.
So if it's not, because you're putting it below the import, it'll already be there no matter what.
Yeah.
Because I was worried about it not being loaded and then calling for the
Yeah. Yeah. So, now that would, and like you were kind of saying, the next time you come in, and it wouldn't matter if you didn't have this. It would suck in whatever was there. But when you're actively developing and or making changes, it's something you kind of have to consider. Yeah. The other thing you could do, I guess you could temporarily move it into the main PYT file until you're ready and then pull it out. Yeah. But, yeah. yeah, it does kind of throw you off. You're right, yeah. Mm-hmm. Yeah. All right. All right, well, I'm going to be at the island for a little bit, so if anyone wants to come by and have more questions, feel free.